We haven't yet done a two-sided integral, so I just want to show you how that works. Recall that we basically define, when we have the integral from negative infinity to infinity, we define that as integral from negative infinity to infinity of f of x is equal to the integral from negative infinity to c of f of x plus the integral from c to infinity of f of x. In other words, all we're doing is we're just going to pick some arbitrary value c, where we can break up this integral into left side and right side, and it doesn't make any difference where we do it. Since we're going all the way from negative infinity to positive infinity, the two sides, when we add them together, are going to be the same. It doesn't matter where we break it up. So just to make it interesting, I could do this symmetrically. This function is, of course, an even function that's completely symmetric about the y-axis, but I could use the y-axis itself, x equals 0, as the point to break it up. But just to make things interesting, instead I'm going to choose c equals 1. So here, again, just to demonstrate the point that it doesn't matter where you break it up. So this is going to equal the integral that we're given, I'll write that as dot dot dot, is equal to the integral from negative infinity to 1 of 1 over 1 plus x squared plus the integral from 1 to infinity of 1 over 1 plus x squared. That's going to equal the limit as, by definition, that's going to be the limit as a approaches negative infinity, the integral from a to 1 of 1 over 1 plus x squared, plus the limit as b approaches positive infinity of 1 to b of 1 over 1 plus x squared. So, you know that the antiderivative of 1 over 1 plus x squared is the arctan function. So this is going to be the limit as a approaches negative infinity of arctan x from a to 1 plus the limit as b approaches positive infinity of arctan x from 1 to b. Now, the key to understanding how to do this is you need to know what the limit of arctan x is as x approaches positive and negative infinity. The arctan function, I don't want to go too much into this because this is really a pre-calc slash early calc 1 topic, but the arctan function looks like this, where it has horizontal asymptotes at pi over 2 and negative pi over 2. So we can see, just from looking at the graph of the arctan function, which you can see is really just the tan function reflected in a certain way. You know, the tan itself looks like this. It has two vertical asymptotes, so when we flip it around to form an inverse, we get two horizontal asymptotes. What we can see is that as x is approaching positive infinity, the arctan function approaches pi over 2, and as x approaches negative infinity, the arctan function approaches negative 2. So we can basically just use that fact and see that this is going to be arctan of 1, which is pi over 4, minus arctan of negative infinity, which is negative pi over 2. And then on the right side, we're going to get arctan of positive infinity is pi over 2, and then minus arctan of 1 is pi over 4. We can see is that pi over 4 and negative pi over 4 are going to cancel each other out. And then we have negative negative pi over 2, which is positive pi over 2, plus another pi over 2, and that gives us pi. So the yellow area is in fact pi.